are live. Are we live? Right. Good afternoon, everyone. Hey, yeah. Oh my God. Suddenly, so many people have joined in. Good afternoon, guys. And it's nice to be talking to a camera alone in a room and looking at the chat box. Uh, yeah, I wished I could see you all, but I hope everyone is doing fine and things are good back home. And it's a different kind of normal, so we have to run with it. Good afternoon, everyone. Sanjay, Devanshi, Anisha, Ramakant, Dia, Sumira, Ayush, Vaibhav, Sanika, Aditya, Sachin, Ronak, Divya, and so many people. Oh, it's nice that you have joined in for the stream. So, the video is going to be available even after, of course, the stream is done. But since you have joined in, it's very important that you raise questions, and these become some pointers for things that will go into the video, right? And let's see how it is. I hope the sound and all is good. Just give me like a wave if the sound is a problem anywhere, or if there is anything any kind of problems, then just put it in the comments and we'll go ahead. Good afternoon, Mayank, Mohammed, Fahim, Alvin, and so on. So many people. Hi, Ayush. Yeah, okay. Okay, so let's start off. I mean, we shouldn't keep it for so long. The stream is going to be pretty short, I think, since it's the first day. So we'll just do one thing. We'll just take a look at how the course is going to be structured, and it's going to be a very difficult and different thing doing this course like this in an online manner, because you know it's primarily a hands-on course. I don't know if you've noticed, but the course credits was something like 104, right? So 4 is the practical component, so which means you were supposed to have 4 hours of at least 4 hours of workshop time, but that is like unfortunate. So we'll have to do this in a more theoretical manner, but then I thought we can take this opportunity to learn a few things that we wouldn't normally would have learned, right? So my idea is that apart from doing some of the assignments which I think could be done in your homes and wherever you are, right? Apart from that, we'll try to learn a little bit about 3D modeling. uh, Demon Gaming, your cycle chain got stuck. I don't know where were you coming from. Anyway, good that you are here. Who is Demon Gaming, by the way? I mean, if you can just tell me your name. Uh, anyway, let's move on forward. Let's take a look at the slides, right? Mm, okay. Welcome to day one, and we are. This is the course syllabus. I don't know if you can read it. There will be some problem with the loss of compression, but the slides as they are right now, I will upload it into a convenient platform, and you guys can you know see it later on. Right? Demon Gaming is Amir. Hi, 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 Amir. Right. Why have you retracted the message? I saw your name. Anyway, okay, so let's move on forward. So the course content is primarily related to manufacturing of metals, right? So we have we'll be talking about the way in which you manipulate material to get the desired products or parts or components that you need. And this is the overall course syllabus, and it is about we'll cover most of these things, but then we'll also cover a few additional things. Happy Teachers Day also, Priyanshi, and to everyone. Right. So we'll talk about the history of manufacturing processes, some properties of materials. We'll talk about how metal can be manipulated in three different kind of states in which it is in. Right. So one is like when it is a hard state, when it is like solid. One it is one where it is semi-solid. Right. When you have partially heated the upper material, it becomes softer, and you could use some manufacturing processes to manipulate it when it is in that state. And then finally we will see how metal can be manipulated when it is in a liquid state, which is generally casting and all that, right? So these kind of three different tiers of manipulating materials are there, and that we will take a look. Besides that, there are some different types of processes, like what you can see is powdered metallurgy, where we use instead of solid metal or liquid metal per se, we used powdered metal, and that's also a very interesting way of manufacturing things and metal things, right? So we'll take a look at that. And yeah, so that's about it. Regarding the books, there are two books that I really love. The first one, I have it open right here. Okay, yeah, you can't see me. Just hold on. Right, right. So this is the first book, right? It's called Manufacturing, Engineering, and Technology by a person named Kalpakshyam. I hope I'm pronouncing that right. Since this is on YouTube, I hope I don't end up in something like live stream fails or something. But yeah, let's move on, right? Okay. Okay, let's see a bit of a okay. I was talking to you about the second book. The second book is I don't have it with me here, but that book is called Rob Thompson Manufacturing Processes for Design Professionals. It is an excellent visual book, right? So you have all the manufacturing processes laid out in a very visual medium. You can see and relate and understand visually how that process would work, right? And what are the limitations of that process and so on. So if you want to know a lot about the technical aspect of the process, then this book is what is important to you. If you want to know about the general overview of the manufacturing process, what are the different kinds that are there, and also what are interesting designed products have been made out of these, then you can uh, refer to this other book, which is Rob Thompson's Manufacturing Processes for Design Professionals, right? Uh, so I do have both the books in PDF files, but I will not distribute it to all of you. I will if you I'll send a mail about this so you can check that, right? Okay. Okay, right. Uh, okay, let's move on to the plan of the course. Okay, so this is our schedule of the course. The first and foremost, we have five 3-day modules, right? So 3-day modules. We'll not obviously we will not do like a whole full day work. We'll have 1 hour of lectures, like probably like this only. If this seems to work, then we'll do it like this only. And what we will have is we'll try to cover certain topics in each of these modules. Like the first module, we'll try to look at properties of materials, idea about tolerances, and we'll look at machining. Unfortunately, machining is something which really needed like hands-on, right? But I mean, somewhere in the mid ground you will be during our last to last batch, right? The batch who is currently in the 4th year. During that time, what we had done was we had gone through the whole workshop, and we had made some videos of the machines, right? How the machines work and what they look like, and we also made some videos about hand tools. Okay, Jason was very kind enough to help me with the video shoot. So he made these videos and he edited the videos, and I also think he's uploaded these videos in his YouTube channel, right? So subscribe to Jason, I guess, right? And so these videos we can go through these videos slowly, and we'll try to decipher what kind of tools these are and what uses they have, right? Okay, so then the second module we'll continue with machining a little bit, because it's slightly a bigger, you know, theory component to it. Then we'll introduce 3D modeling. So this is what I was thinking. Instead of, you know, getting to do hands-on in the workshop, I have substituted that part of the learning process with an introduction to 3D modeling. I know there are other courses in your next semester which will introduce you to 3D modeling in depth, right? But here we will use this as a launch pad to get familiarized with the software and to also use it in some of the assignments, right? So this will always give you an edge to you when you are doing some other kind of assignment, some other courses assignments, right? So we'll do 3D modeling a little bit. So I'll do like a tutorial session of one of these softwares. We'll do Fusion 360 because it is really accessible, and it's really powerful, and it is free, right? How many of you know about Fusion 360? Can we have some hands-on? Bhavika is asking if we can have some hands-on after you're back in campus. Oh no, that is Chaitanya is asking. Right. Chaitanya, make your own Gmail ID, man. What the hell? Yeah, we can. See, I think this whole Corona thing is, I mean, the effects of Corona is going to spill over to the next semester also. We might have Saturdays working, so I can't really, you know, give you a promise that we will definitely be able to do this. But yes, so for this I can't force you to do this, right? So you would Chaitanya hates Google, right? Uh, okay, so we are doing it on Google, by the way. Okay, anyway, right. So what we'll do is in the next semester, if you guys are interested in actually getting your hands dirty in the workshop, then I want you to come forward with some kind of small, design project which you could make. I mean, like not too complicated, like very simple. Like let's say make. Um, I don't know what, a pencil case or something like that, or you know, just a small. I'll show you some of the things that people have made. So let me just switch on to the full camera view. Just give me a second. Right. Okay, so one of the assignments that we've had previously was a cutlery assignment. It was a very interesting assignment because it seems super simple, right? But when you are actually get down to the brass tacks of actually making it, then it becomes tremendously difficult, right? uh, yeah, Blender, you can use Blender, Anirudh, but I would rather you use Fusion 360 because there are some benefits and pros and cons of Blender. Blender is primarily a entertainment design oriented software, right? By that I mean it is primarily used for in the animation and film and VFX industries, right? So it has most of these tools and are catered towards that. So what differentiates Blender and Fusion 360 is the precision, right? So in Blender you can give like a dimension between two things to be 2 mm or 5 mm or whatever. um, but once you know start modeling and manipulating the model, that dimension will go for a toss, right? So whereas in Fusion 360 you design or you model by dimensions, okay, by dimensioning as far as possible. I mean, that's the best way to model, right? So if you want to make a box, you give like, okay, this box is 200 mm on one side, right? And the other side it's something XYZ. Okay. uh, right. The real question is, when is next semester? I will not answer that. Why is Pranay saying weapon? Okay. uh, right. How about Maya? Maya also is the same thing as Blender. Maya is a paid software, and you should not do piracy. Okay. Madhav, you understand, no? Piracy? Yeah, don't do piracy. Okay. Right. So Maya is also the same ballpark figure as Blender in terms of, you know, usability and all those things are concerned. But right now, I mean, I want you to pick up Fusion 360, because once you do this, you know, there are other software categories which becomes much more easier to pick up. So these categories are called parametric modeling. Okay. Anyway, I'm rambling about 3D software. Let's move on to other things. I wanted to tell you about these other things. So in the next module, we'll look at plastic phase manufacturing. Plastic phase manufacturing is not the manufacturing of plastics, but rather when the metal is in a sort of a state which is technically defined as plastic, right? By that I mean when it is somewhere in between a proper solid and a liquid. Okay. uh, yeah, Fahim, let's keep this, you know, discussion of the 3D modeling to, you know, that only. Let's just say I am saying you have to do it in Fusion 360 because it's you have to learn it, right? Okay, so that is the part which is instead of workshop that we'll be doing. Okay, let's move on. Finally, we will. Okay, as you can see in this plan, every module there are 2 assignments that are going to be there, right? So the first assignment I'll introduce you today itself, okay, and you don't have to submit it till the next module, or rather, okay, uh, you have to submit it 1 week after this. So like, for example, on 7th, if I am introducing the assignment, right, let's you have to submit it by, let's say, 14th. Okay, so next week Monday. Okay, so similarly 1 week after. Okay, why 1 week after is because I will get 1 week to check your assignments, and when the next module starts, we'll have a small discussion session on who did nice assignments and which submissions were interesting, particularly interesting, and so on. So you'll get an idea. So it's not be possible for me to, you know, pull up every assignment and give you feedback. I know all of you want that, and I want to do it, but given the way in which we are doing this, that is not possible, right? Okay, so let's so we'll do like a sample of assignments, and we'll you know uh, we'll what was I going to say? Yeah, we will check these sample assignments. Okay, so yeah, okay, so fine, yes, okay. There are a few things that I am adding into this course which are not there previously. So first things is, I am going to introduce you to injection molding. Injection molding is the process of manufacturing plastics, right? Or rather, is one of the process of manufacturing plastics, is the most versatile and the most widely used one. So it makes sense for us to introduce that process here itself, in this course itself. And then we will introduce to you, I will introduce you to production practices. You know, besides manufacturing processes as such, we also have something called production practices, which enable you to effectively, you know, employ these practices, processes. right? So by that I mean, how do you ensure that the production is going smoothly? How do engineers ensure that production happens smoothly? How, what considerations should designers think about when designing products so that it is easy for the production line? Okay, so these kind of things we will talk about. And finally, there's something called embodiment design. Most of you know this as detailed design, right? So detailed design is really, although it is a fair terminology, but embodiment design makes more sense for this course. Embodiment design is how do you embody the product, how do you give the product a physical dimension or physical form, right? Okay, so we will introduce these two things. Mind you, this is just an introduction, so that means we'll do very basic things and we will just tell you, okay, this is how things work, right? Oh, and again, finally, to assignment. So the next thing is, how are we doing the grading? And this is the most important part, I think, right? So this is how we are doing the grading. We have 10 assignments and we will do 8 marks each assignment. Okay, we will have 2 quizzes sometime, and this will be like surprise quizzes. I still haven't figured out how we will do quizzes in a because I honestly, I don't want you to Google, because it's like very simple questions and it'll be based on whatever I've discussed in the lectures and so on. So now that the lectures will be online, so it will be very easy for you to scrub through some videos and get the answer. Uh, but I don't want you to do that. But I haven't figured out how I would enforce something like that. So if you have some ideas, then do share. I am right now thinking of using OneNote. Okay, so I'll show you that how it works. Right. Okay. Second is, the AS grade will be based on overall performance. Even if you are scoring high marks in the because of the submission of assignments and all of that, it doesn't guarantee you that you will get an AS grade if you've done, let's say, all the assignments and so on. Now, it will be based on your overall performance in all of these assignments. So if I see that out of the 10 assignments you've done 8 of them excellent, right, better than the rest of the class, or better than the best average, or the better than the best submissions, then I will probably grade you an AS, right? The rest of it will be based on the marks that you obtain, and finally an F grade will be given if you don't complete if you complete less than 4 assignments. Yeah, A is fine, Fayaz. Yes, good. You work towards that then. Yes. Okay. Right. Okay, besides this, let's give you some more information. So I have these. So the way generally I do this course is, whatever assignments you do, you have to document it. There is nothing like you put one picture in a presentation and submit, हो गया, ऐसा नहीं चलेगा. So you have to document it well, and you have to submit it in this folder, right? So as I said, I will give you the whole slide, so you can just copy paste the link from this slide and see. So there is something called OneNote. Are you aware of it? I hope you are aware of it. OneNote is a note-taking application, and we have this Microsoft license in the institute, so we are using OneNote, right? OneNote helps me, track your progress through the course. So I'm trying to use this OneDrive folder and OneNote application. So let me just pull that up, and I will try to show you. Okay. Right. So this is OneNote, and yeah. So I don't know if you've used OneNote before, but I think now if you log in to your OneNote account, you will have I think if you search, no, you will have a link where it says you've been added to this OneNote And here for you, you will only have these few things on top, like you will have the welcome, you will have the collaboration space, and you will have content library and so on. And for you, let's say Aditya, for Aditya, he will have these sections there. So what I can do is I can just make let's say I have made this test. Okay, I made this test note. What I can do is I can distribute this page to all of you, right? So I will distribute page to uh, right, so let's say reading material. Okay, I will distribute it to all of you, and once that is done, you should have in all of yours reading material. It's not coming yet. Right, anyway, I think it will come in after some time. Yeah, once this whole thing is done, it will get distributed to all of your OneNote. So I am going to give you the link of this presentation, the link to any reading materials and all of that through this OneNote. So you need to check this regularly. Whenever I upload something, I will say that I've done it over here, and you can just go and check. And here there is a way to do the quizzes also. So I think I can make a quiz and kind of distribute it through the same manner, and you can put in your answers when and let's say I give you like time of, let's say, 15 minutes or 20 minutes or something like that, and you can put in your answer and you can submit. Then I can check for every student when he goes into the right. So now you will have a test note in every this thing, everybody's note. So like this quizzes also I will distribute. That's the idea right now. If I find a better way, then I will do it in that manner. Okay, right. So that is OneNote introduction. Okay, and this is the link for the OneNote. Sorry, this is the link for the OneNote. Okay, and this is the uh, link for the drive. Okay, so let me show you that also. Okay, okay, let me pull that up and show you the drive. Right. So this is a drive. So this is a drive of assignments done by the previous batch, and the idea is that in this drive you will have a folder for your own of your own, right? So let's say I will just see Anand's folder. So you have to rename the folder in a certain manner so that it's easier for me to check what you have done later on, right? So I can see that Anand has what all he has submitted, and he has named the folder. So everybody has to do it the same way. You have to name your folder first name dash 004 is the roll number, right? So then again inside this you have to do like M1 D1. So instead of M1, so earlier it was module 1 day 1 assignment, module 1 day 3 assignment, something like that. But this time we will do like module 1 assignment 1 A1, module 1 A1, M1 A1, M1 A2, and M2 A1, M2 A2, something like that. We will do like a normal simple code, and within that you can paste some of whatever submissions you've done. Okay, try to keep the submissions in the form of images, PDF files, and low data intense formats, because it becomes very heavy sometimes. So yeah, so I'll show you what they've done in one of the assignments. Can you see this? Can you see this? Yeah, so this is a cutlery that they've done. So let me pull up the other, right? Okay, so this was made in the workshop. So this was one of the first kind of assignments when or rather I think the second assignment or something. Yeah, it's the day 3 assignment. Okay, so here this is like a spoon. Okay, and it was so this was the idea that you would make a cutlery set, and I hope people can see, right? Okay, you make a cutlery set of a spoon, a fork, and a knife, right? And they did something like this. It was quite interesting. This is one of the designs. There are many others, and they are very, very unique. Like this one, for example, this is like a completely. Let me get it in view. Okay, so this is like a knife. Okay, and this is a spoon which goes with it. Okay, and it's all machined aluminum. Let's do it here. Yeah, it's all machined aluminum, right? And yeah, so it's fairly unique. Then there are some assignments which were done for just understanding machining, like this one. This is I think it's a top. I don't know, you can see it. Yeah, against my shirt, I think you can see it, right? So it's like a machine top which you can just spin like this. So these are the kind of simple assignments that we generally do. One of them was fairly complicated, like this is a pencil, right? This is a machined pencil, and it works. So you have unscrew it. You have this one piece which is threaded, right? Okay, and you have this one piece which kind of has like a lead attached to it, and there is something inside also. I don't know if you can see, if the camera focuses, right? So there is something inside also which kind of holds it in place. And yeah, so this was one of the more complicated assignments. It partially works. Okay, anyway, so these we will not be able to do it physically, but we should be able to do it digitally, right? So whatever assignments that you are going to do, let's say we want to do a machining assignment, or of, let's say, making a, let's say I give an assignment that you make a pencil. Okay, I think I'll probably definitely give an assignment which says let's make a pencil. Okay, and you will have to design it and develop it in a CAD software, and show it to me. I can analyze it through the CAD software also, that whether it can be made or not, and based on that I can give you marks. Okay, right. uh Inception. Yeah, it was an Inception totem, I think. Okay, let's right. Okay, let's move on. Okay, so now base after this we kind of get into the territory of what this course is actually about, right? Let's talk about let me just give me a second to clear the thing. Okay, so let's talk about the course. Okay, so this course, what exactly is it about? Why are we doing this course? Why do we need it at all? I think many of there are going to be some apprehensions and comments that you make internally. Why are we doing this course at all? For product designers, definitely it directly makes sense, right? So for product design, you have to know how things are made and so on. So this, that's why the course is there, right? So but what about the interaction design? What about graphic design? Does this make sense at all? Well, yeah, this course is actually about enabling design. You have to uh, so through the process of learning about these manufacturing processes, you are going to appreciate how to bring a design to life. Okay, this idea is applicable to all the fields, I think. So definitely for product design, you will have a direct linkage, but um, for every step that is there, let's say in product design, there is a similar kind of a step, or I wouldn't say similar, but like a analogous step in interaction design. So take it in that perspective. Okay, and go with your um, go with an open mind with this course. And we will definitely learn few things about product design. We will learn a few things about the properties that you want to impart to your designs, and what materials help you achieve those properties, right? Okay. uh, as I said, this is primarily about metal manufacturing, but we will definitely speak about a little bit about you know non-metals, right? So we will speak about how do you we will speak about glass and ceramics, and we will briefly cover plastics, as I said, through that injection molding topic. And we will briefly talk about wood, but we'll not go in deep into wood, because wood is like a whole different territory altogether. It's very very hands-on, and to learn about wood, it doesn't make sense for you to go through a presentation. You have to actually do the work with wood, right? Okay. Yeah, so this is one of the most important things that this course will teach you. It will teach you how to talk to an engineer. So as you know that in a product design, in a product development process, there are hundreds of people. There are people in marketing, there are people in sales, and lots of in between people, right? Design is a component in product development, right? Although it is pervasive, I mean, that means it goes from it influences from marketing to the sales, right? It's pervasive through all of these, but it is still nonetheless a component within the whole product design process. Similarly, engineering is a component. Okay, it is again pervasive in nature. So it's important for design and engineering to talk in a product development scenario, right? They have to talk in terms that uh, people understand. Okay. More often than not, engineers find it difficult to understand the language of designers. When designers talk about form and so on and so forth, it's difficult for engineers to make sense. But we can do our part. We can learn about engineering. I think our courses in minor courses are helping the engineers to learn a little bit about designers or design, right? Similarly, we have to give an effort to learn a little bit about engineering, and we have to learn to talk to engineers properly. Okay. With By properly, I mean using the same kind of language. And so this is a kind of a language that this course will tell you about, this language. Okay. And finally, this is one of the most important things, is to build an innate inquisitiveness on how things are made. Okay. uh, I so all of us have different interests when we go into YouTube, and we want to do some time pass. Okay. uh, so somebody would look for music, somebody would look for something. So I have this very curious thing, I think, is I kind of spend my time looking at these shows and videos of how things are made, how people make things and so on, right? I try to do that myself, but I don't think I get enough time, or I'm just cribbing. Okay. Anyway, so I really love how these things are made, or how people make things also, right? So this is an inquisitiveness that I want to pass on to you. So probably uh, the next time the algorithm suggests you things to watch, if it suggests you things to watch about how things are made, then it'll be a win. Okay. It means that you have found interest in this course. Okay, so that's a way to look at it, right? Okay. So that's it. So let's talk about so now we are getting into properly into the territory of the class. Okay, let's talk about mm, materials. Okay, let's start off with this. What are the different kind of materials there are? Typically in the class, I won't even say a word on this slide. I mean, what do you think there are? That's the kind of questions I would raise, and I'll just go through the slides. Okay, so I think everybody knows this, right? Yeah, yeah, Chaitanya. Algorithm is the problem. Yes. Right. So let's run through this. Everybody knows this, yeah. So what are the kind of materials that are there? I think some of you will know, um, s- will have heard about some of these for the first time. Okay. So metals, there are two kinds that primarily I think you all are aware about. There is the ferrous materials and there are non-ferrous materials. And non-ferrous are the ones which do not have Fe, right? Fe is iron, right? So iron is such a, what should I, a godly material. Hyperbole, a little bit of hyperbole, that iron is such a godly material that it deserves a category of its own, right? And then there are others, right? So there is copper and there is aluminium and so on. Although aluminium, yes, we are seeing it more and more uh, uh, in the world of late, but steel is something that drives the world, right? Steel, and so steel is based on iron, right? It's an alloy of iron. So ferrous materials deserve a category of their own. That way, there is a third category, which is the amorphous metals. Okay, so now this is a little bit of an advanced kind of a concept. Most ferrous and non-ferrous materials, um, they have something called a crystal structure, right? I think everybody knows about crystal structure, right? So crystal structure is how atoms in a particular thing are in a particular material are arranged, right? You have learnt about this in class 8th, I think. Okay, so most metals are crystalline in nature, and there are, however, some metals which can be made amorphous. Okay, are amorphous or can be made amorphous. Okay, and using specific manufacturing processes, you can make these some materials amorphous. And amorphous materials do not have a very large crystalline nature, or they may have crystals on a very smaller scale. I mean, where uh, in a but that crystalline nature does not affect the properties, whereas the crystalline nature in ferrous and non-ferrous affects its properties. I think that's why, there's like this three categories. Okay, besides that, there is plastic, of course. There are two types. I think everybody is aware of this. One is a thermoset, one is a thermoplastic. And it's very simple. Thermosets are uh, plastics which, when they are becoming, uh, they undergo a chemical process when becoming solid. Okay, that's like a layman's way of explaining it. Okay, thermoplastic, however, they do not undergo a fully chemical process when they are becoming solid. They have a liquid, no, liquidy plastic, let's call it plastic phase. Okay, from now on we'll call it plastic phase. They have a plastic phase and they have solid phase, right? So they transition between these two. Okay, and uh, these are primarily polymers. Okay, plastics are primarily polymers. There is another category which is elastomers. Okay, again, MERS is basically MER. MERS is a way of defining these chains of chemical chains which are very very long in nature, right? So it's a repeated chemical element which is repeated, and it forms a long chain, and that is what is a polymer. It's a Mer is a single thing, and polymer is a multiple of the Mer, right? So Mer is the chemical compound. Okay, so thermosets are these kind of polymers which undergo a chemical change when they are becoming solid. So typical examples would be something that mostly you are aware of, I think, is epoxy. Okay, so if you've seen that M-seal, right? So M-seal is an epoxy. So you have two different components, which you have a hardener and something else, right? So you mix these two together, and there is a chemical process which happens, and it becomes solid, and that is a plastic. So that's a thermoset plastic. Okay, thermoplastic is, I think you've heard mostly like polypropylene and ABS and these kind of names are thermoplastics, right? So these are typically thermoplastics are typically used in injection molding. However, thermosets can also be used, but the process is slightly different. Okay, so elastomers are the third thing. The third thing, elastomers are things like polyurethane, silicones, and rubber, right? Natural rubber is also could be called an elastomer. Okay. Why is Vaibhav saying hydrocarbons? Hydrocarbons. I think yeah. I understand. Okay. Right. So besides that, there are some naturally existing materials which are extensively used in design and engineering. Right. So these are glass, ceramics, and refractory materials. So glass, I'm sure everybody is aware. Right. Ceramic are something very close to glass. Right. So ceramics. You will probably have food and cutlery things made out of ceramics, right? And then refractory materials are a third kind. So these materials, so refractory materials have a very high melting point. Okay, so much higher than metals. Okay, so these can be used, refractory materials can be used to cast or hold, liquid metals. Okay, so they don't disintegrate when holding liquid metal. Okay, so these are used extensively in casting industry. Okay, for lining these cauldrons, or it's not called a cauldron, but to help you understand, so these containers where liquid metal is stored, right? Okay. Right. Okay. So the next is in terms of next are purely natural elements which are used in design and engineering, like fibers, wood, and so on. Right. So we'll not go into that, but the final category, again, people are aware of things like this, are composites. Okay. So composites are when you have two different kind of materials joined together, and they work homogeneously as one material, right? So one example, yes, we do have we don't have a ceramics lab yet, but we have the space for ceramics lab, and I think we were trying to set it up last, answering Pranav's question. Okay, do we have a ceramics lab, and is there a plan to set it up? There is a plan to set it up. There is a space allocated for it, and I think there was some problem with the budget in the past year or so, because of which we couldn't do it. But me and Supradeep sir and a few others were really keen on getting the ball rolling. But I really can't comment on it right now because I don't know what is the status of that. Anyway, okay. So moving forward, composites are these when two materials are used together and they perform as a single kind of material. Okay. Okay, so let's go forward. What is manufacturing? I think again this is one of those slides where it is an interactive slide. Okay, it's not supposed to. It's not for me to talk on. So so what is manufacturing? Manufacturing actually is slightly hard to define. Okay, manufacturing is just not making things. It's not just that. Okay, it's it's um, it's about how you think about it's how you think of making things. Okay, it's how to make intangible things tangible, right? It's about understanding of materials, what should be used to make these things so that it's the best one possible and in the cheapest possible costs and so on. And it's about the processes. Definitely, it's about how do you cut, shape, or join various things, and it's finally there is also a component of techniques. What are the best ways of doing it? Okay, what are the good ways of doing it? So these four kind of aspects: design, materials, processes, and techniques combined together to form the knowledge base of manufacturing. Okay, manufacturing science and engineering. Okay, right. Okay, so let's do a little bit of this. This series of slides presents you about history of manufacturing. I think you will see most of the slides have some kind of question. How old do you think Okay, I think that we can type in the chat box. How old do you think manufacturing is? I don't Google. Okay, the how old is it? I'll wait for the comments. I think, is there a delay? Yeah, there is. I think a significant delay. Yeah, it's very old. Mohenjo-daro. 1500 years, 20,000 years. Very, very old. Quite old. Right. Stone tools manufacturing. 1 AD? You think Jesus did not have anything manufactured on his body? Aliens. Right. Most of you are very correct, right? 10,000 BC and all that is as old as civilization itself. But the documented history of manufacturing, right? We have found solid documentation about it as far back as 5,000 year BC. Okay, before Bronze Age. Stone Age itself, yeah, correct. Govardhan is correct, right? Stone Age itself, you can think that manufacturing already started because people wanted to make these, stone tools to do some specific things. So to learn, so here in this set of slides, I will only tell you like very briefly. I will just kind of do a time wrap of the whole civilization or the history of manufacturing. But I suggest you watch this really cool video by uh, I think one Professor Stephen. So I will link that. I will not link that in the description down below. I will put that in the OneNote folder, and you can see that. And it's very interesting, and it tells you what makes manufacturing evolve, right? Okay, without so going ahead, let's so this figure that you see is one of the, it's called the dancing girl, and it's made out of bronze, right? Bronze is one of the oldest materials which people manipulated. Okay, and uh, manufacturing typically is an artisan trade. That means it's become like an established science. You can very clearly define, you know it's almost become mathematical. I mean, you can clearly anticipate how a certain material would behave if it is put through a certain process. Okay, and that it's become like that exact science mostly. I mean, most of the things, it's still, there's definitely a lot of art in that. Sorry about that, right? Okay, uh, but this is a bronze statue, so it tells you that as far back as 5000 BC, people were able to manipulate bronze in such an intricate manner. Okay, now the India has a very interesting relationship and history of manufacturing. And it's very interesting to read India's contribution to the whole manufacturing knowledge, right? So one of the things India was very very famous for was something called was steel, basically, right? Okay, I'm sorry, Pranay. Sorry. I think I'll just give me a second. I'll just make sure that such accidents don't happen in the future. Right. Okay. Going back, I'm sure everyone's fine. Yeah. So when I say India, I think back then Sri Lanka was not really Sri Lanka, right? So this, let's not call it India. India is a very political boundary, right? So this whole South Asian geography, right? That was famous for Damascus and wood steel, and this steel was exported from India to somewhere in the Middle East. So existing Syria, for example, and they made these amazing blades, which were legendary, right? And in, I mean, referencing pop culture, the I think Valyrian steel from Game of Thrones, it was inspired by this idea of Damascus and wood steel blades, so this is only a figure. Nobody really exactly knows what Damascus and wood steel looked like, but I think now if you uh, do a Google search and see how people are see these knife making process, some people claim that they have made it in like a Damascus steel blade, a knife, and so that, yeah, Valerian. uh, Devaditya suddenly woke up. Yes, the Indian subcontinent is what I meant, right? uh, okay, okay. The other thing that India was quite famous for was zinc manufacturing. We'll not go into this, but they had like a very innovative process of zinc manufacturing, and zinc was one of the very famous exports from India, right? This is like quite back, and quite long back, right? Okay. uh, Interesting thing to note is that apparently Damascus. I don't know how true this is, right? But I remember reading it somewhere that Damascus steel, the if you analyze it under a scanning tunneling microscope, uh, if you analyze it under a very strong microscope, you can see like carbon nanotubes within its structure, right? So it's the idea that some way of manipulating material, we would reach this stage that you could form carbon nanotubes within material is astounding to me. Okay. Anyway, so moving forward, so we have 5000 to 4000 BC is what we understand the manufacturing started, and primarily during that time people used to manipulate meteoritic ore that was found, or meteors that had fallen into the ground which had a lot of impure materials, and that could be manipulated in some manner to manufacture certain things. And then slowly pottery was one of the prime ways to manufacture things, right? Okay. So pottery is done by manipulating clay, and then you could fire that clay. That means you could heat up the clay to a certain temperature and it would harden. There would be some chemical processes which would happen inside, and it would become like a ceramic. Okay. So terracotta was, I think, the first type that was made. Terracotta is fired at a lower temperature than ceramics are much higher temperature. So once people figured out how to reach those high temperatures, they could make ceramics and so on, right? So initially they so it mm, so 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 as the knowledge around the world grew about how to manufacture things, people slowly started making better quality products and more faster and things like that. So the other, you know, initial historical manufacturing processes were related to wood. Okay, so carpentry was one of the uh, things that drove manufacturing during that time. So think about this, no? So let's say, um, uh, how would how would this idea help, let's say, an animator, a person who's animating? So let's say you're designing a, I'm digressing, but it's interesting to think. Okay, let's say you are designing a village in something 3000 BC, and you are you are supposed to make the house look like a 3000 BC year old house. Okay, what kind of materials would you use to build that house? You are an animator and you have to think about that. Okay, so you would have to think about, so primarily these kind of things would help you, right? So you would think, okay, what were the manufacturing processes available at that time and what could have been done with those kind of processes, and with that you could slowly build up this world, right? So that's an interesting way of doing it, right? Okay. Okay, right. So next, slowly as we learn to increase, or get control over temperature, we were able to manipulate glass, and glass blowing was one of the things that is found to have been originated very very early on, right? So especially I think Venice, Italy, became like a hub for in Europe for glass, and everybody knows about like this Venetian glass and so on, right? Next, right. After that, we slowly came to, you know, uh, manipulating metal. Okay, so first earlier metals that were manipulated were, you know, brass and bronze and copper, because these are softer in nature. And then we have some very very good examples of people manipulating metals from that time, right? So we, by the time we reached around 100 VC, we were able to cast iron, and we were able to make armors of these intricate designs and shapes, which will need some very special way of manufacturing, right? So the picture that you see on the side is a person making a Japanese katana. Japanese katanas are an amazing example of mastery over steel. Okay, and so yeah, so there. Finally, yeah, I mean, even in India, there are some very good examples of, how people were able to manipulate metal. So the picture that you see on the side is Tipu Sultan's cannon. I think it's in one of his castles, and imagine this huge single block of iron, how it would have been made. So people had to have mastery, and on top of that, if you see it close enough, you will see these intricate details and form that is given to this whole thing. And you would have to give it to the people of that era, how learned they were in manipulating metal. And this is, think about this is like 1300 to around how many years from now, and people were able to do this. Then slowly, I mean, by that time also, China was one of the places where porcelain trade was booming, and uh, I think porcelain and ceramics were one of the things that were you know transported through the Silk Road. If you know, the Silk Road was going from China to somewhere in the west, right? So yeah. Well, then we come to the modern age, and after that, we started having these kind of manufacturing process that we are more familiar with today, right? So things like the lathe machine, the milling machine, and things like that, no, those were invented. There are very interesting accounts of how manufacturing processes helped people in war. Okay, it's very strange that during war times, somehow manufacturing process kind of gets a boost, right? Because you have to make things for the troops, and people would want to make things faster and more cheaper and so on. So because of that, the people would be forced to think of ingenious ways of manipulating things, and during that time only very very interesting technological breakthroughs in manufacturing had happened. Looks like, for example, one of the things was very interesting was this production processes, right? So this earlier manufacturing, before this time, before this case of Eli Whitney. Okay, this is a very interesting case. So before this time of Eli Whitney, what was primarily the way of manufacturing weapons was, you would make each and every part, and you would grind it, cut it, and all of that, and you would join it together. So one person does the whole thing. Okay, and Eli Whitney, I don't know much about the background of this person, but it will be interesting to read. But so Eli Whitney, in his factory, he tried making muskets. Muskets are these large guns which I think were used in the American Civil War, right? So the way he made the muskets was, he could interchange parts of one musket to the other, right? So he standardized these things. Okay, so he standardized the parts of these guns. Okay, so because of that, what happened was, it was possible for people to repair things more easily, to manufacturing more number of things, and ensure that one thing fits on the other part that was made. So this was a breakthrough in production engineering. Okay, uh, right. And I think people know about this story about James Watt. Do you know what? Do you know what did Watt make? Right? What is credited with making the first steam engine? I think, if I'm not wrong. Okay, correct me if I'm wrong. Okay. So the story goes something like this: James Watt was very close to finishing his designs, but there are a few things that he couldn't do. He couldn't make the cylinder through which the piston would move. Okay, so it was difficult for him to do that. So he enlisted the help of, I think, John Wilkinson. Wilkinson was another famous industrialist at that time, and John Wilkinson, during war efforts, somehow manufacturing processes kind of okay, not during war efforts. There are countless examples of historical stories of how manufacturing came to be, right? Okay, and also there are countless examples of how war kind of affected the innovation around manufacturing processes. Okay, we'll not go deep into it, but it's an interesting read if you want to search for it and read it. Finally, we come to the modern age, and the we so the thing that drives the innovation in the manufacturing process are three things. It has to be faster, it has to be cheaper, it has to be better than before. Okay, if you are able to do these three things, then that's how progress is made in the processes, right? So by 1800s and all that, we had these very very interesting manufacturing processes called shaping and milling and so on and so forth. And by the 1950s, we really understood the materials and science behind it, and things like EDM, like electrode discharge machining, TIG welding, tungsten inert gas welding, and so on and so forth. These kind of things came about. Okay, right. Okay, and finally we come to the newer age, and now I think the biggest revolution in manufacturing which is happening is 3D printing, although it seems like it's fairly old now, right? So it's 2020, it's the corona year, and I think by how many years has it been since 3D printing? Like 50 years? That's what I'm guessing. Okay, I'm not sure. Okay, again, correct me if I'm wrong. Right. So one of the very interesting developments, like pivotal developments in the recent era in manufacturing, is in production technology with something called Toyota Production Systems. Toyota is the company which makes cars, right? And they've had a huge impact on the manufacturing industry, and they've primarily, it's the way of managing production. Okay, so the Toyota production system is the way of managing production. I don't know if you've heard about these terms, but maybe you haven't heard, but there is something called 5S of organizing your inventory. Okay, 5S's is, and these are Japanese words: Seiri, Seiton, Shiketsu, Shitsuke, and something else, right? So I think, uh, so 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 they developed this kind of philosophy which have been implemented world over. So it's a pivotal moment, Toyota production system. And finally, we've entered like this age of digital manufacturing, where all our work happens inside the computer, and it can be brought to life with 3D printing methods. Or it's not called 3D printing, it's called additive manufacturing. Okay, so now we'll, so but there are like major, you know uh, gaps, not, I shouldn't say gaps, but like ethical concerns in the whole thing. One is like a very straightforward thing, like take a look at this image. Okay, so I found this off the internet. You can see kind of what it is. It's a 3D printed thing. Okay, and there is hardly anything that is required that you need to buy off the shelf. Okay, like there are only, I think, only one part that you will have to have trouble getting. Okay, this is a gun. Okay, and it's very scary that this can be done, right? So yeah, I mean, there is some discussions in ethics and the way manufacturing process, the ethics and responsibility of manufacturing, which I think this course shouldn't really go into. But this is something that interested students can pursue, read about, and get a good knowledge on. Okay, so this is an example. So that one was plastics, and this is like metal. So you could 3D print, you can easily 3D print metal, and you can, if given the right, as soon as you have the digital data, you basically have the physical part. Okay, so it makes it difficult, or it makes it rather easier for people to steal data. Okay, and get away with bad things. Okay, so that's how the world is moving today. And yeah, so right, so we should do like a breather right now. Okay, so I have a few questions here. I think I can answer them. The first one is, what's the difference between porcelain and ceramic? They are basically the same thing. Okay, what Pranay is saying is, I think fairly correct, and it depends on the material or the composition, and the temperature at which you fire it. I mean, fire it and you bake it. Okay, the way ceramics are made is something like, it's bread. Okay, you make a dough. Okay, you give the shape to the dough, and you put it in an oven, and you wait for it to bake. Okay, and once it bakes, yeah, it becomes hard. Okay, so that is how ceramics are made. That's like a, explain me like I'm five kind of an explanation. Okay, and right, and porcelain is a type of ceramic. And yeah, porcelain is finer and higher density. Ceramic is more porous and absorbs more water. I'm not sure about this, but maybe it's true. I need to check this. Okay. The man accused of killing two people in Germany yesterday after falling a break into a synagogue stated in his manifesto he had 3D printed parts for his arsenal. Yeah, exactly. Thank you, Chaitanya. This is like, that's what I'm talking about. So it's like a major ethical concern. I think this is not just about 3D printing per se. I mean, it'll be vilifying that, knowledge base, but if all kinds of digital manufacturing. So there are a lot of digital manufacturing processes right now. Okay, so by digital manufacturing processes, I mean um, the primary, planning of making something happens digitally. Okay, and once that data is ready, that can directly be fed into a machine, and that machine can do the work of building that part. Okay, so within this, if this is the way we define it, then the category, then there are several processes that fit into this category. One is definitely additive manufacturing. Okay, uh, is yes. Well, yes, I think if you know about that, one can make a gun if they want to without a 3D printer. It's quite easily. If you know about that, I think you should keep it to yourself. Okay, yes, don't do that. Okay. Anyway, right. So where I was, digital manufacturing, right? So the other digital manufacturing aspect is subtractive manufacturing, where you take a piece of metal and you subtract material from it so that you come out with a certain part that you require. Okay, so this is yeah. So this is another way, and something like CNC machining is in this realm, right? Okay. Uh, let's see other questions. There are other questions. Right. Okay. So moving forward, let's move forward. Where do you get bullets from? A good question, Devanshi. But I think Ace has the answer to all of these. Ace, please don't share the answer. Okay. So let's move forward and let's go on to the next slide. I want to go to the next slide. Right. Okay. So there are four. If we categorize manufacturing process, there are 5 of these categories. We can clearly see. I think besides that, there is definitely something else which is there. This is not be all and end all, but this is one way of categorizing. And with these categories, we can see when when we were able to do this process for a certain type of material, or the uh, subsidiary processes of casting. When were we able to do? For example, we were able to cast gold and copper and meteoritic ores by around 4000 BC. Yeah, so this is really 6000 years ago from now. Yeah, we were able to do this, and we were able to make wrought iron by 2000 BC and so on. And something like die casting, and which, okay, yeah, have you seen like hot Hot Wheels cars, the good quality ones, not the cheap ones, but the good quality ones, they are made with metal. Okay, and they are, I think they are aluminum. Okay, so these are made using a process called die casting. And even if you go into these collectible toys sites, you can find these die casted cars. So automotive designers would be very interested in this, that they generally get these kind of small toys for their desks, right? So you can get these die cast cars, and they are made, the way they are made is there is a die, which means there is like an A part and a B part, and they close together, and the gap that is there, which is created inside, you pour metal into it, okay, and when you remove it, the metal comes out. So these two dies have to be made with certain material which doesn't get degraded with liquid when you put liquid metal inside it, right? So that kind of process is called die casting. We'll speak about it in detail later on. So that happened very recently, actually. Similarly, forming is a way of manipulating metal when it is in a soft state. So when you heat metal to a red hot state, it becomes softer, okay. So that when it's soft, you could hammer it and give it a shape, okay. So that is process is called forming, and we were able, so this is naturally, you can, by the way it sounds itself, it's fairly rudimentary. You just heat material and hammer it. So that process is a very old process, but slowly and over the time we have learned enough about it that we made some exotic ways of exotic forming processes, like there is something called an HIP process, which is hydrostatic something. HIP process is a forming process for, I forgot the this thing, hydrostatic, isostatic, forgot the full form, okay. HIP process is used for forming, okay. Anyway, let's go forward. So joining, the ability to join, die casting is not profitable for bigger versions, asks Shreya. It is. So let's say the size of chairs also, you could die cast. Okay, you could die cast chairs. Beyond that, I think. Beyond that, I'm not fully aware if very large, let's say like ship propellers, that size, right? That size, whether it can be die cast. Probably not, I would say, because that would mean that the whole die needs to be that huge, right? So probably not, but let's say the size of engine blocks, definitely. Engine blocks is not die casted, but I think it is a different kind of casting process. I think it's sand casting, but maybe over the course of time, things have changed, and maybe it's die casting, okay. Looking at joining process, we'll the way you join metal is it's not changed, okay. So the way you join metal is you melt both ends and you join it and you wait for it to cool down, okay. That's joining metal, okay. Now you could do a few more things, like for example, instead of melting both the ends and putting it together, I melt both the ends, yes, and I put a third material in between and then I join it, okay. That's one way. The other way is I don't melt them at all. I put a third material, and put it in between, so that the third material bonds with both these two materials and works properly. So that's the third way, right? So that third way is called soldering, okay. And the rest, let's say joining material, is welding, okay. Now there are different ways of welding, like what you can see here is something called forge welding. If you take two pieces of material, put it together and really hammer the hell out of this thing, okay, you put a lot of force, then you will have made enough frictional heat between these two that it flows into each other, okay. So it has forged together. Joining plus casting, well, no, like for example, what I was saying was something like welding, okay. So normal welding, right, where you have these two materials, and when you put that welding rod there, what it actually does is it heats up that place locally, okay, and it heats up enough that it melts it a little bit. So once you come back in the next semester, I promise you, we will do a workshop tour, and I will definitely show you all of these, tools and materials. So during that time, you will probably get a hands-on how to do welding. Okay. And once you do that, you will realize how actually welding works is those two materials melt, and that melt kind of flows into the gap that is there, and then these two join together. Okay. Right. Then machining is the way of removing material. Hmm? So what happens, what you do is, how long has the stream been going for? Sorry, let me just check. Okay, I think we should stop in some time. Okay, this has been very long. Just give me a second. Right. Okay, so machining is the way of removing material, and you can remove material by ensuring that one part really spins very fast, or like moves very fast, and the other part is there. Okay, so it moves very fast and it cuts. Okay, something like that. Yeah. So that is the way lathe works, right? So you have a spinning object, and you put a cutting material which is harder and stronger than this base material, and it can cut through, right? So you've seen lathe machine work in, it's a very common process. I think you have seen it. Okay. Finally, compositing is the way of, you know as I said, taking two different materials with different properties, combining it together in a homogeneous fashion, such that the resultant material has a different property of its own. Okay, a better property than these two individual components. So everything in non-material, in non-metal, such as most of the things in non-metal such as porcelain, ceramics and glass, use this kind of manufacturing process, and it's fairly old. Okay, so this slide gives you that idea. Right. I think we will not discuss this slide in this class. Okay, we'll stop the stream in some time, and we will discuss this later. Okay, so let me just do the next slide. Okay, which is about damn, this I missed, but anyway. Okay, I hope you can see the slide. Okay, it's the first assignment. This is the day one assignment, which is product knockdown. Okay, I'll show you examples. The idea is that you take a product and you uh, open it up. Okay, open it up to individual parts, and you figure out how as a whole the product was made, right? Assembled basically, and how each and every part was made. What do you think each and every part would have been made with? Okay, you can do specific processes directly. You can say something like this was die casted, and or if you don't know, just get a understanding based on the shape of the material. Okay, on the shape of the part. Okay, and think about, okay, yeah, I think this was made with casting. Okay, so that much information is fine. So you have to give three types of information for each part. Okay, first is how each of these parts were made. Second thing you have to give is what material is this, most likely, right? So it would either be plastic, steel or aluminum, or in some cases it will be like brass, copper, things like that. Okay, but I will give you a slight extra, I will be slightly more lenient in marking you higher if you can figure out the exact material. Okay, so like plastic, what exact plastic? So do you think it's ABS? Do you think it's polypropylene? Do you think it's something else? What exact metal? Do you think it is spring steel? Do you think it is mild steel? Okay, this kind of, it's a little bit of a jump. I know that you haven't learned about these kind of different materials, but on your process of searching, if you realize these kind of materials are there, then it will be much easier for you to grasp the things that we'll discuss in the next classes. Okay, right. And then the idea is that a toy would do, yes. So I can ask, if you have any questions, you can put it in the chat box and I'll answer them. uh, so what you have to do is, you have to take about the product, you have to take photos of individual parts, and the photos have to be nice. Okay, you can't have random photo ki yeah, ऐसे ले लिया, ऐसे ले लिया, ऐसे ले लिया. No, not that. You have to set up, you have to make a setup, and it's very easy to make a setup. Find a place where there is nice sunlight, and uh, place a chart paper or something. Okay, and in the so that you have a nice background and all that, and use your cell phone, or if you have a proper camera, use a proper camera, and take a photo in a manner that the form of the part is clearly visible. Okay, it should not be like, when you see the photo, it should not be like, okay, I don't really understand how it bends and what features are there inside. So if there is a part which is like a cap, okay, let me show you something. Let's say it's this kind of a part. Okay, it's black. Now this itself presents to you some challenges in photography. So what you can do is, you can have some interesting lights. Okay, take an extra cell phone or take a torch light or something like that, and you shine light the part in such a manner that it's you can see the different, form of it. Like for example, in this one there is a like a thing that comes in inside. Okay, and it's not like a cap, it's not a cap actually. Okay, it's a holder of this pen tablet. Okay, anyway, so you have to be very clear. Okay, the next thing is, it is not supposed to be in a group of two. This is a mistake that I made. It's individual assignment. Okay, it's not a group assignment. Okay, so it's an individual assignment. I have to be very clear on this. In the presentation that I'll make available to you, I'll put it as individual. Finally, you have to make a nice 10-minute presentation, or you can make a document. Okay, you can make a single document which shows different parts and different photos, but it has to be composed very well. Okay, and on top of that, whatever you want to do, you can do. Okay, so this is an example of a product knockdown done by Anant. Okay, Anant is in BDES 3. I think he's in BDES 3. Okay, so he took pictures of, so he disassembled a pedestal fan, and he took pictures of these different parts, and he made this very interesting GIF too. And it's but this is not the target. Okay, this is I'm showing this because I want to give you an example of what kind of products you can take. So you can take like a pedestal fan, it's okay. So it has I think it has more than 20 parts. Okay, but he went through each and every part and figured out how it's made, and what goes into making this, and so on. Okay, now there are a few things that I think you shouldn't do. Like for example, right, okay, so let's answer a few of the questions. The first one, Shreya asks, would a toy do? Yes, a toy is a good enough product, but remember, mostly it will have plastic parts generally. Okay, so try to find a product which will have sufficient number of metal parts as well as plastic parts. So that will be very interesting, right? So if you just keep on encountering, let's say a plastic part, then it will be very weird, right? What will you write in the manufacturing? You'll write injection molding, right? So that's not it will not get you to learn enough. 15-20 parts is too much if from a single object, says Ayush. Actually it's not. So you can see this, right? Technically all you need is a screwdriver. I think you might need a plier also. On top of that, you will also get to see some of these very very interesting hardware that you were not aware that were there, right? So you would get to see these cap nuts and spring washers and different types, so you have to really observe. Okay, here are the things. So all screws, okay, of the same dimension, same type, count as one. Okay, it doesn't count as individual parts. So if you have 10 screws, doesn't count as 10 screws. If the 10 screws, there are 5 screws of one type and 5 of another, those count as 2 parts. Okay, that is, I'll give that to you. Okay, so part count getting to 20 is not too difficult, Ayush, right? What would get us higher marks? If you Ace asks what would get you, I didn't Ace, have you done this course prior? Okay, okay. Before Ace, write the answer. If two things, two questions to Ace. One is, have you registered for the course, and the second is, have you done this course before? Okay. By the time he answers, I will answer the other questions. Okay. What if the object has electronic component as well? Small circuit board, for example, asks Gaurav. It's a good question. You can choose a product which has a circuit board, but this whole circuit board counts as one part, because we are not really going into the manufacturing of electronics per se. That's a whole different ball game altogether. So let that count as one part. So if that is the case, then you select your products like that only. Home studio setup. Yeah, you do a home studio setup, Devanshi. It's going to be very important for you, I think, not just in this course, but in the other courses also. Should the details about all the parts be given or just selected? I don't understand your question, Shreya, but I think you have to. I think what she's asking is whether you have to write down the details. Yeah, you have to put the details in a presentation and then submit. शामिल की मेहनत, ये क्या है पता नहीं. Do we have completely Nico? Who is Nico? I don't know, but I'll answer your question. Do we have to completely disassemble the product? Yes, you have to completely disassemble the product till the point that you can't do it without special equipment. Okay. So there will come a point where you will not be able to remove a bearing from a part, okay, because it is pushed in there. So that counts as one part. But then you can say that this part has a bearing and this whole assembly. So the bearing can be said this is one part, and you can say this is how the whole bearing is made, and so on. Lego toy, Lego piece injection molded, Lego piece injection molded. मेहुल तू ऐसा करेगा तो तुझे 0 दूंगा मैं इसमें, ठीक है? सही से करना असाइनमेंट. Aditya and Surya. Surya, are you in this course? You have. This happened last time. She found the slides. Okay. Right. So I'm not sure, because Ace, I don't know if your name was there. Did you get the mail in the? If Ace got the mail in through that group, then it's a good thing. That means he's registered. I got the email ID, but I don't remember seeing him. Anyway, Surya, I think you check if you are registered here. Do it. I think there's a last date for the whole thing, but do it prior. Shreya asked, I mean, the details about the 15-20 parts only or all? Details about the 15-20 parts. The whole product should be made out of 15-20 parts. It should not have more than that. Okay, as far as possible. Okay, so about all the parts you have to give details. Okay. Yeah, Nero is right in saying don't disassemble any electrical items when they are connected. And thank you, Nero. That's very perceptive of you. Anyway, okay. So, right. I think we've been going on for quite a bit now, and it's a good time to close this live stream. I hope the technical aspects were fine. I mean, the sound was okay, and the camera was decent, and the presentations were visible. I just want to get you know feedback from all of you saying this setup works, and we can kind of do the rest of the classes this way. Otherwise, I will figure out another way. Okay, so so if you can, data limit is always Fayaz, I think you need a good internet connection now. All of you need a good internet connection. There's no other way to do this here. Okay. Yeah. Okay. Thank you. So if the whole setup works, then good. If so, what I'll do is, um, can I show you some of the assignments, or do you think it's okay? Do you think we should end the stream, or let's see some of the assignments from prior? Okay, thank you, thank you. Seems extremely. Arjun, thank you. Way better than other profs. I don't know what other profs are doing. Uh, okay, thanks, Bhavika. Okay. Fahim wants to see. Okay, good. Okay, let's see some of the assignments, right? Okay, let's. I I'll keep the screen up till I figure out OBS a little bit, huh? Uh, Right. So let me just close. So the presentation is over. I will just close the presentation. Damn. Right. Okay. And right. Okay. Just give me a second. Okay. Yeah, I think you should be able to. I think you should be able to see my folders now. Okay. So I'm just gonna let me just do another thing. Um, what the hell? Give a second, guys. Hold on. Drink a cup of coffee or water. Drink some water. Right. So let's do this one. Well, let's see Anand's assignment. So this is what he did for the. So this is what he did for the fan. Okay. So he took the photograph like this, and he said material is iron, which is obviously wrong. Okay. The material is not iron. Iron is a element, is a chemical element, Fe, pure iron, right? So most of these things are made with steel. Okay, I would have been okay with him saying it is steel, but iron is not correct. Right, let's go forward. So in the earlier assignment, I had asked them what you figure out uh, the you find the manufacturing process with which this product is made, and find a video of it in YouTube and link that video. So this is what he's done. For you, that's not important. So what I generally found is I ended up with the same kind of video. So I was expecting people would show me something very interesting and all that, but well, okay. Anyway, so yeah, again, iron sheet is not correct. Remember this: if you are finding something that's made out of with sheet of metal, most likely it is sheet metal. Okay, and you can say sheet metal, but I'd be more happy if you can say it is made out of steel. Okay, mild steel or something like that. Okay, so this is the motor and its holding unit. So you can see that he's disassembled till whatever. So this is the motor unit, right? So this center unit is the motor unit. Can I draw on it? I can't draw on it. Okay. So this is the motor unit. Shit. And you can see he's not been able to disassemble it as much, right? And this one also is the rotor of the motor, which he's not been able to disassemble. This counts as a single part, but it's important to know how it was made. It's not made in a single step. Okay, most of these parts may be made like for example, this fan blades are made with this in a single step, in a single kind of a process. Okay, and if you just give that one kind of process, it's okay. But some things like this, no, it's not made with in a single step, it's made within several steps. So you have to know, tell me about all of these steps. Okay, this is the material that is used. These are the 5 different types of materials that are used in this part. This is how this whole thing, this part is manufactured. Okay, so it's going to be slightly difficult, and you need to rack your brain on this. Okay, you can see the pictures, and it's good pictures. It's clear and I can show you. That means they are good pictures, right? So let's see something else. What does he have here? uh, right, so this one is also the same thing, a little, you know, is it was not complete in a single slide, so he made like 3 images. So let's see somebody else's example. Let's see Joel. What is this? uh, Not this. Ash. Give me a second. Right, okay, let's see this guy. Okay, so Prakash did a knockdown of a mixer grinder. Okay, earlier this was done by 2 people, so let's just go through what they have done. Okay, so he's done like, this is the body, this is made with polycarbonate, injection molding polycarbonate, which is wrong, right? So this is not made with polycarbonate. Most likely it is made with polypropylene. If it is a high quality product, most likely it would be made out of ABS. Okay, so right, so you can see in these photographs there is a problem. Like for example, the details towards the inner part of the product is not clearly visible. So I don't want this to happen in the ones that you submit. So if you end up with a photograph where you can't make out the details towards the end or under the product, you put a small reflector at one side. Okay, you'll get the reflections on this. By reflector I mean white piece of paper. Take a white piece of paper, put it near that, the reflected light will shine on this part and you will be able to see these details more clearly. Okay, I think you will have like, do you have product photography course also? I think you do, no? Okay, okay. Right, okay, so let's move on. So everybody has done it in a very interesting manner, like uh, let's take a look at this. Sorry, till it loads. Can you just tell me uh, if everybody's got the message? I mean, like the mail through the group, because that is the way I will communicate with everybody. Okay, so yeah. So tell me that and tell others to join into the live stream when possible. Okay, let's do. Yeah. So he's done this, right? So that's what he's done. And yeah, so you go through all of this. Okay, so I think Prakash got some good marks because he was able to figure out these kind of different screws in that. See, it's not just about knowing the way it is manufactured. If you are able to find new knowledge that we did not discuss in the class, or something that you realized when you are searching for this product, that counts. Okay, so that counts as learning in this course, and you have to put that learning somewhere. And if I see that, and if I see that this guy has put in the effort needed, then yeah, I'll be happy. Okay, so let's play this again once. It was quite interesting. So this is the product and this is the exploded view. Okay, that's why the explode, it was fun. Anyway, okay, we will stop the live stream here. If you have any questions, first of all, let's see if there are any questions. First of all, let me just transition to full view. Right. Uh, okay. Okay. So if you have questions, type in now, or we will stop the live stream. If you think it was fun, say bye, and don't forget to subscribe, I guess. And, yeah, okay, or wait for the next class. Okay, so we'll do the so tomorrow is the same thing. We'll do the class at 3 o'clock, and we'll move on from there. Okay, yeah, okay, I'll see you guys. Yeah, no, Priyanshi, you don't have to make the exploded view, but it'll be I mean, if you put the effort into doing it, it'll be nice, no? Preferred format of presentation, there is no preferred format. At least it should be something that I can scroll through. Yeah, nice. Thank you, Sanay, and leave a like. Yeah, don't forget to subscribe. Bye, see you guys. It was a nice class. Yeah.